Back, we got a stepper motor pulled off. I've got our little thing here, set screw. Let's take this off. Wonder why that stuck to that. Alright, no longer needed. Now let's get the tap and die set here. And we need a 3mm, I think it is. So we're going to take this piece here, we're going to tap this out so it makes it easier to thread those screws in. Yes, this was a metric tap and die set that I had bought just for this kind of purpose. Okay, I'm back. Now let's see if we can get this mounted to this. These are like 10mm M3 screws. They're 10s, they may be 8s, but they barely go through. Which is good. They won't hit the belt. Shouldn't. Alright, so let's do this. And get this mounted on there. The Allen wrench seems to be getting buggered up. Alright. We should be good to mount it up. I want to make this go into the inside. Oh, I was gonna say, you're kidding me. I thought I made that hole big enough. Hell, I said I thought I made it big enough. I must not have. Already went in print and shrunk, so I am going to have to what it is. Get the larger drill bit and take care of that. Okay. I use my Forstner 7/8 inch Forstner bit to clean that out. I think that's what those are called. That slides in there. Ooh, that's a problem. Don't go all the way in. Huh. I should have not had that issue. That's bottoming out on that. So that shank's too long. It tells me I'll have to drill out that shaft in there. Because I want that to go flush, but we've got a gap there for the motor mounts. It's always something. Well, I'll drill this up to this point here with a 5mm drill bit. I am now going to reset this with a set screw so it won't slide all the way through, or not slide all the way through. Not double negative. Because I need it to slide that far. That. Did I get it right the first time? Well, if that's the case, let's torque it down. And then we'll mount that way. Take the 4 screws used before. And you'll be happy to know that I ordered a set of metric Allen wrenches for a drill. Should be here tomorrow. I do not like that. Why is that wobbly? Something's not getting tightened up. Oh, are these screws bottoming out? Screws are bottoming out. Son of a. Needless to say, we need to go to a smaller screw. That royally stinks. No offense to you royals. Let's see what these are. I don't know that I've got one step down from an S. 18s. Now let's look and see if I've got a 16. Let's try this again. Much better. So yeah, I need to order some more 16s because I do not have that many left. Like I said, these were the smooth head. I'm not sure where I got those from. Ooh, just about lost all my pack of ABS washers. This is what I'm got printed up. 1, 2s, and 3s. So you just have to go through and figure out. Route 1, based on height. Now I got one or two options here. I can either go back and modify my model to be, which I got to modify the model anyway because that opening should not be that tight. But I can either make it thicker, which is probably what I should do. And then use the 18mm screws. I think that's what I'll end up doing. Because if all this works, I've got to do a whole other side. So this in theory will be 1/2 of the overall round Skyliner. Okay, let's start this out. So I've got a 1-to-1, and a whole bunch of little guys. Oh, let's go ahead and set all these roller bearings in. I'm going to see if I can find a block of wood to put on the back side of this to keep from putting marks in the back side. Hard maple on a chessboard, but I have not finished yet. Hard maple should do the trick. Yep, that did the trick. Alright, so that's got all of our roller bearings in there. Let's see if I can do some cleanup on this real quick. Alright, so this one will go here. I'm going to do the same thing we've done in the past, which is put it together as it goes in because there's not enough room. And that being said, we need the belt. I don't know. God. So, right off the bat, we got a loosen this up so we can get the belt on there. Spent all that time doing that and forgot. Let's see if that's enough slack to slide 2 belts in there. Okay. Torque it back down. Okay, we're back to where we were. Let me just tighten these down. Probably need to put Loctite on them, but until everything is settled, I'd hate to go through and do that because it's a pain to get them back free. I'll probably wait to see if they start backing out and do the vibration and then put Loctite on them at that point. Okay, just got 2 belts there. Let's get our 1 belt. Let's see how we did the other one. Did we do it on the inside or the outside for the first belt? So the first one was all the way on. against the motor, so that'll be that one. The only reason I'm doing this is to make sure I maintain consistency. Makes it easier to troubleshoot, I think, in the long run. Somebody don't want to go in. So do I. Plenty of slack in the belt, that's for sure. That went in. We'll go with it. We'll see what it does. Alright. Already made up. Get the belt that way. Let me just make sure. I step down. So I've got 3 gears. I got the 4th one is the step down. That's correct. The belt. Except we do not need this washer. Unless this side is tight. That's what this little short one is for, that'll cut off. boot up the old Pi and see what it does. Spinning. Got a hum to it, but it's nowhere near as loud as the clicky clack of all the Lego gears. Only thing is, I think, yeah, it's turning the wrong way. Interesting. Because this is the lead outside, so it needs to be rotating counterclockwise, which I thought we had done with the code. Let's see, Pi nano RPI test Pi. Right now we've got it going. Just realize this says it's 100 RPM. Let's bump this to 180. And then let's see, where are we telling it to go counterclockwise? It's got clockwise true. So we're doing, we're calling ribs RPM clockwise true and clockwise fault in the second go around. Once it passes the first 20. So let's just comment that out and make sure we get it going counterclockwise just right off the bat. Instead of waiting to see after 20. Python 3 RPI test. And then it's going clockwise. Why does it think? We're calling that function, rotate no ramp. Rotate no ramp. Clockwise equals true direction. Clockwise else GPI low. Oh, we're coming up that block. So I never bother to rotate, so let's put this block back in. F clockwise. Else GPI low. That works fine. Oopsie there. Deal is. Let's fix this code here. I totally messed it up. So F clockwise. F clockwise. GPIO. High. Else. GPI. So I do GPIO dot output direction. GPIO dot then else. Let's see if that don't work. That ain't right still. Clockwise. GPI output high. I'm telling it. GPI output high low. Well, I do not know. Let's try putting this back in and only do it for 10 rotations. Interesting. So, true does counterclockwise. So we need to change our text. So if clockwise was. Do GPI low and then do high. So clockwise, counterclockwise. Perfect. So let's up the number of revolutions because I had it down way too low. Let's put it back to 1,000. It's actually pretty quiet. I'm impressed. But again, we've not stepped it to where it's having to pull the whole chain of 20, or no, that's not 20. 1, 2, 3, 12. Sorry. Oh, something's happening. Is it wearing the gears off? That's not a good sound. Not wearing the teeth on that. Not wearing the teeth on the belt. But yet it looked like it was slipping. Ideally, yeah, I'd like to have a belt tensioner, but there is no way in the world. Well, I can't say that. I could build something that goes here and has push, but is it overkill? Probably. Well, it seems to work. Um, let's get it to run the other way real quick. I think I'm gonna change that down to 100 instead of 1,000. That sounds great. Yeah, we'll see how it does. All right, on to the next one. So, oh boy, we don't have any more. We've got one. Does not make any sense. Let's screw it up on the. Oh, there it is. It should be 7.94, 9.29, 9.31 to 1307. So I think this is the combination I'm looking for. So on here, we will again go 16 tooth. On the inside, just check and see if the 96 work. I don't think it will. Let me check and see if it will. Here's the problem with the lift gear. You don't want to put a big bill on that. So I'll see if we can make it mine. Do this flush. Just in case it does work. So I don't know. I'll do it again. Yeah, I see. Just make sure we're going to pull that out. Yeah, there you go. Okay, yeah, we'll shut. So we get the hundreds. They say right tomorrow. Love. Quick living. That's gonna be a booger to get. So that's cool. Watch this again. Let's see what I got in this one. So straight one. Let me set it on the back side. So parts are pretty clear. You're 9 hours. Give or take. Oh, right here. You can go here. You can stay right here. And hold it right there. We're going to have to do it on the other one. Make it push in. I don't know how to do this. But looks like it's these on tire. Let's remote it. Anyway, for business maintenance, heavy duty things, yeah, sure, using the pulleys, they have using motor and tires. Each one after motor one. That's expensive. Better left. And up. Okay. Go back, put a bigger spacer behind these. This area here, make sure they stay off. You'll see. I have jumped ahead here. I've got my 100mm belts in, so I've got those there, here, here, and here. And I do not have a piece printed to mount back in here. I thought I had it, but apparently not. But I wanted to try running this and see if this will actually work or not. So we are going to connect to this Raspberry Pi. And hope it works. Hot dang. Let's let it run for a few minutes and see what it does. Some odd noises, not sure why. Could be just vibration. I don't know, man. I hear a pause or a skip or something. Seems to be okay. The next step will be to get this piece mounted on here, and then we will need to get the tires mounted on, and then do a test run if our gondola is actually going to go down through there nice and smoothly and kick out the backside. So that'll be our next video.